welcome back. So now we have the sofa, we have the landscape, we have the you know the the lighting built in, the post processing in as well. So everything is there. However, we still this is just a precursor for for building the game, which is going to be a top-down survival game. Now it's all good that we learned a lot about landscapes. We learned it from scratch, and we also built this whole level from scratch along with the landscape. But this is not level building course or level design course. This is a course that will teach you how to build a game, a top down game, which is going to be a survival sort of theme game where you have people coming in, where you have enemies coming in, and you have to use WSD or the arrow keys to run around and use your left mouse button or your right mouse button to either attack or send magic projectiles to kill them, and you keep on hitting them until they die and until a swarm is done. So there will be a swarm of enemies that will be coming attacking towards you. You either have to escape them or run towards them, attack them, and that's the whole game. So it's good that we built this landscape from scratch, and it took us a while to build this whole thing along with the lighting and everything else. So now let's get on to actually building the whole game itself. So this is the starting point of building the game, where we start off by creating a character blueprint, and then we start importing the character mesh, and then we start importing the animations, then we start creating the materials for it, and then we start writing the logic bit by bit by bit until we finish it off with UI, and we have a full game in hand where you can publish it and you can send it out to your friends for reviewing. So before that, the first thing I'm going to do is I'm going to be creating a folder inside content, and I'm going to call this blueprint. Okay, and inside blueprints I'm going to be creating a new blueprint class. Okay, and this time I'm not going to be creating an actor or pawn. I'm going to be creating a character, because this is a top-down game which has an animating character running around and chopping people off, and the AI enemies also are pipette characters, human characters who have swords in the hand. They have run animations. They have sweeping with the sword animation, dying animation. So the best bet in our hand right now is a character. So a character is actually a type of pawn, and a pawn is type of an actor. So this is how the hierarchy goes. But the character is more specialized in a way where you get a lot of specialized functions, where you get a lot of specialized components for that particular blueprint, as opposed to a pawn or something else. So if you have a pipette, or if you have a four-legged animal, or anything that has a humanoid form, can be used in a character blueprint, because you have a lot of functions that are specific to these kind of assets, these kind of characters. So I'm going to be creating a new character, and I'm going to be calling this character base, right? So this is going to be a character base. So double click on that to open this, and I'm going to quickly show you what it's got. Okay, so let's just take a look at what this character blueprint has. So now we have this character base. The first thing I'm going to do is I'm going to go save and compile on success only. So every time I click compile, it also saves it. So I don't have to perform that extra operation of clicking on the save button there. So this is what the character blueprint looks like. First thing is it has a capsule component as the parent component. Okay, and the capsule component is what you're looking at, the capsule component. Now, capsule component is a bounding box, sort of like a collision bounding box, which encloses your character, and this this comprises of the height of your whole character, and the base of this capsule is where your character stands at. Okay, so that's what the capsule component does. And if you take a look at this, you have all of these normal collision aspects as well, which you can change if you want. And but we won't do that right now. Just wanted to show you that it's pretty common. And next up, you have this arrow component. The arrow component depicts where your character is looking, which is the forward vector for your character. So if you have a character, if you have a cube, or you have a humanoid character who's looking this way, then that's what this arrow does. So of course, this arrow can be brought in, and this arrow cannot be really, in fact, this arrow cannot be really changed directions, but you can definitely say arrow component. So that's where this comes from. But this is completely inherited. So if I say arrow component, this is a different arrow than the arrow that was inherited. So every time you see inherited, it means that it was built inside C++. Okay, and this is not something that you can add directly. So if you want, you can look at this, but it's not something that's exposed out for a normal person inside Blueprint to add directly from the editor. But just to point it out to you, Anything that you see as inherited it means that it's been created inside C++, so it's got a C++ class. Okay, and next up you have the mesh, which represents the mesh of a character. So out here in the details, if you look at it, you have the animation section, which takes in what kind of blueprint it uses. So it says, you can say that for animation mode, use the animation blueprint, or you can just use, if it's just a simple asset which just has something, a very small thing, then you can just say use animation asset directly, or custom mode, which you're not going to get into. Now, of course, we haven't created any animation blueprints. We will do it. So in the future, when we create the animation blueprint, you're going to be able to see that in this list here. Right now, we don't have it, so it's not there. So in the future, you're going to be able to see it here, and you'll select that, and the mode will also be use animation blueprint. Okay, and then you can also select the mesh that you want from here, like normally. All right, and then next up, you can say you have this character movement, which is the essence of this whole blueprint. Now, without this, this is just going to be another actor component, or sort of actor blueprint. Now, this is something again which came from C++. This cannot be removed, so you can try and remove it, but you can't. You can try and remove this. You can't even actually try and remove this, because these are the default components. These are the required components for a character blueprint. So when your blueprint is going to be inheriting from the character, out here it says the parent class is character, then all of these components along with this definitely has to be there. And this normally, in normal circumstances too, cannot be removed. Okay, if it's done from C++, because it's inherited. And if you right click, it says open character movement component.h, right? So that's where it's an indication that it was done in C++. Now, if you do that, if you right click on all of these guys, you can still see that you have all of a corresponding H file, right? So that's how these components are made. Again, if you right click here, and you can also see the capsule component.h. Now, this character movement component is incredibly useful, and this is what separates from a normal pawn. So here, if you look at the details, it has incredible amount of information about bipedal movement and locomotion and character movement and physics interaction, and a bunch of other things which are extremely useful for you to simply get into, you know, set things up really quickly without having to getting into plumbing a lot. So for instance, you have this general settings where you have all the max acceleration, the mass and everything, and we also have the character movement walking, where you have the max walk speed and all of these things, little things that where you can directly change, you can directly key in some values, and you can see your character behave in a different way without having to work out a lot, right? So having said that, that's a very brief introduction to what the character blueprint does. Having said that, let's get started with first adding a mesh inside. Then let's adding by first adding a mesh for this particular for the skeletal mesh here. Okay. So if you click on mesh, and if you look at skeletal mesh, you can only see that these two guys are there. But we don't really want this. Okay. For now, before we don't have this character imported in yet. I just wanted to show you something that you can do with the character component pretty easily. So we don't have skeletal meshes, and we're not going to import any right now. So what I'm going to do is I'm going to go over to the top, and I'm going to add a static mesh. Okay, I'm going to add a static mesh, and this static mesh is going to be something really simple. And this is an experiment just to show you how things work inside the world, inside a character blueprint. And it also looks a little ugly, but it's okay. So I'm just going to look for some static mesh that I can add. So maybe I can look for a cylinder. There's no cylinder. Cube. There's no cube. I think there's something called a barrel. So we can have a barrel. It says barrel, wooden barrel intact and damaged and destroyed and damaged. So I'm going to go for intact because I don't want a broken barrel. So if I click on that, there you can see that this has come up. Now it's okay if it does not really, touch the base of this capsule component, which is perfectly fine. It's just for testing purposes alone. So I'm just going to hit compile, save, go to the main arena, and I'm going to drop this guy, let's say, out out here. I'm just going to drop him here, right? And when I release him, and you can see that he is exactly sitting on the ground with the capsule, the base of the capsule hitting the ground, and the barrel is still sitting above the capsule, which is fine, okay? Which is totally fine. We don't really have to work on that yet. We just want to see how this guy can move around. And there's one more thing I'm going to do. Go back to character base, and with that static mesh selected, I'm just going to type nav, And here it says that can ever affect navigation. It says whether this component can potentially influence navigation. I do not want this component to actually block my navigation, so I'm going to uncheck this and compile and come out of that and go back here. Okay, so now that we have this barrel guy inside, so the next thing I'm going to do is I'm going to add a navigation wall. I'm going to explain what that does. So over to the mode section, just look for nav, and out here you can see a bunch of things. Now what you have to pick up and drop is the nav mesh bounce volume. So when I pick up and drop that, I'm just going to drop it here, right here, and I think I'll first get this guy and post processing volume. So I'll just move him away because I don't need it. He's unbound. So this guy can be in the center. So I'm just go over to the top view, and I think he's in the center, or no. Let me put him in the center of this arena. So I'm just gonna put him in the center of this arena. Okay. So what this does is it actually lets you add a volume which represents the navigable space of a character, be it your own character or be it an AI character. Okay. So mostly it's used for AI. So if you want the AI to behave where you want an AI to move from this point, let's say for instance, but this area has to be navigable. If this path is not navigable, then he's never going to be able to find this. Okay, and this also lets him find the shortest possible path. So if he has to reach from this stairs to this stairs, then he will find the shortest possible path and he'll get there. Now, it does not mean that he always finds the shortest possible path, but he should also be allowed to walk from this area because it should be allowed. I don't see any possible obstruction or any possible reason for him to stop walking from this area to this area. So what this thing does is it just defines a navigable area for your character and the AI character to walk on or to navigate on. Okay, and of course this is a very small area. So what I'll do is go over to the details section and look for the brush settings here, and I'll increase the box size. So I'll first go to the top view and I'll see, let's say I say 5,000. Okay, and I think I should just increase that by, let's say, 8,000 because I also want people to navigate here. Like that. I think 7,000 is good. No, 7,000. I think that's okay. I think that's okay. Now, again, I'll have 7,000 on the Y as well. 7,000. There you go. And that's perfect. Now, of course, maybe a little more. Let's say 7,100. A little more, 7,300. So I also want this to cover this area, 7,350. And if I look at this, maybe I can, if I just move this around, it should cover that area as well. There you go. So that covers pretty much everything there. And at the same time, I also want to give it a Z value of, let's say, 500 and not to be too high. And of course, I look at my perspective view and see how big that is. And if I look at this, then it should be the height of this wall so that this wall is not navigable. I don't want people to jump over this wall and chase you, or even you should not be able to jump over this wall and go around. But that's pretty cool. And now, now this navigable area has been set. If I hit P, watch what happens. It all turns into green. This just shows that this whole area is navigable, which means that you can actually navigate through this area. Now, of course, even this place is navigable, so people can actually walk around here. That's a slightly not really what I wanted. Maybe I can just decrease, or maybe just bring it down, or maybe just decrease, maybe 450. Okay, and I think it's still there. So we'll just keep on playing with values until we get the right amount. I think we'll just keep at 400. Okay. If it's still there, then what we're going to do is I'm going to keep this at 500. I'm fine with that. And I'll just bring him down slightly, ever so slightly, like that. And there you go. I think, nope, he's not. So I'm going to move him back to 0 and let him do all that. I think he is way too high. So I'm just going to bring him down like that. I think it's too down. Control Z, and that's good. So 274, so 275. Okay, so we can have that at 275, and then just look around here and just take a look. If I go to top view, I think I can have a better perspective. So this is navigable, this is navigable, this area is navigable. So pretty much every area that I wanted to have it as navigable is navigable, and that's awesome. Of course, people won't be able to go through this place. That's okay. That's just for ornamentation. It doesn't serve a real purpose. And except for this area, which is a little close to, which is a little close to the wall itself. So what I can do is maybe I can just move him a little bit to the left or up that. And let me see. He's still there. Maybe a little bit up. He's still there. So what I can do is Control Z and Control Z. So I'll go back here. So this is fine. If you're really very picky about it, what we can do is we can look for a cube and look for a cube. If you look for a cube and just drop it here, say here, and go to the top view, I'll just pick him up a little bit and push him there. And first I'll go to the top view and I'll decrease his size like this to the width of the wall or thickness of the wall and bring him here. Now I'll just say, I think that's the whole wall. Let's go even further down like that. Okay, and of course I'll just increase this all the way. All the way to here. Okay, and then I'll just hit Alt and I'll duplicate him to this point. Okay, and then I'll just go over to the perspective view and I can see that, and maybe I'll just further decrease the height of the wall like that, almost negligible. And if I bring him down, it doesn't work. Maybe just a slight up like that. I think if I push him out here, just a little bit here. Okay, I think that's okay. And I think I can delete this guy and I'll just go over back to the top view and I'll just say alt drag it and put it here like that. So, and then what you can do is you can click them both. You can go over to the collision area. And first thing is you can say actor hidden in game. You don't want to see that actor. And second, you can say that what is this going to do? The collision preset is going to be invisible wall. Okay, that's an invisible wall. And we can do the same thing over here as well. So if you go back to the top view and alt drag it, put it here like that, that's going to take care of that. And you can see that this is dynamically changing as I'm moving things around. The navigable area, which is represented by green here, is dynamically changing. And I think this also needs the same treatment. So I'm gonna alt drag and pull this guy and put him here and go closer and take a look. Maybe this is good. And maybe if I push him here a little bit. Okay, and do the same thing out there as well. So all of these actors are hidden in game, so you won't be able to see it, but it's going to do its job. So this area is not going to be navigable, which is, I'm totally fine with that. That's a very small area. And then again, I go to perspective view and I can see that now it's there. Okay, and you can toggle this on and off by clicking on first, looking for the nav bounce volume, and you can just hit P and that will go away. Okay, just hit P and that'll go away. If you really want to see that again, so you hit P and you toggle that on and off. Okay, and I don't think you need the navigable volume, nav mesh bounce volume selected. So if you hit P and it comes back on, if you hit it back again, that toggles it back to off. Okay, so that's pretty cool. I'm gonna turn the snap grid on. So that's pretty cool. So now we have this navigation set up. Okay, so if you're just wondering how this whole thing was made to work out, like did, how does it calculate this whole thing? Like how does it know that you should not be able to walk through the walls? How does it know that it should not be able to walk through the fountains? That's mainly because if you go to settings and if you go to project settings and if you click on navigation mesh, so you have a whole bunch of attributes here related to the kind of navigation system you need in your particular project, and also the navigation system out here. And all of these settings, all of these two settings put together, uh, that's how it calculates this whole navigable area inside your level. But we're not going to get into any of these. We're not going to touch any of these because what we have so far is pretty good. You may want to look in Unreal documentation if you want to learn more about this, but we're not going to be touching this at all. And also, the big part of this is the kind of character, whether a character is a big, medium, or small, medium, or big. Now, it understands which is a big character, which is a small character, and which character to put where. So it understands all of that, and that's also taken into account for for making the character run around. And we have a character here which is also set up, which is just a barrel, which will be taken off by the time the next video ends. And in the next video, what we're going to do is we're going to have this barrel move around in a random point in the map. Okay. And so for now, I'll close the video, and when we return, we'll do just that. I'll see you in the next video. Okay, so now that we have this whole thing, I'm first going to get rid of the screen path, because now that I know that it's fine, I don't need any more tweaks like this cubes that we added there, and I think everything else is fine. I'm just going to turn it off. Not turn it off as in I just going to turn it off and not make it visible in the editor. I'm just going to hit P so that it goes away. That it gives me a better idea of where I am. And the next step obviously is to make this guy move. Now, to make this guy move, you have to give him a brain. Okay, and in Unreal terms, when you talk about a character is simply just that, a mesh, and it has some attributes of its own. But however, anything that makes him move around is going to be some sort of controller. Okay, so the first thing I'm going to do is I'm going to right click, and I'm going to go over to a blueprint class, and I'm going to look for an AI controller. It's not going to be there in common classes because it's not very commonly used. I mean, it is, but it's not there. So you have to go over to the all classes and look for AI controller. Okay, and click on this and then hit select. Okay, I'm going to name this AI controller base. Okay, and I'm going to double click that. Now, why do we need an AI controller base and a character base? Well, if this is the body of the character, this is going to be the brain of the character. Now, you might even wonder, why are we separating the body from the brain? Why can't we just have the same thing in one blueprint? Why are we going to separate it in two different places, two different blueprints? Now, the reason being, just picture the scenario. The controller is what that possesses the character or the pawn. Now, character is a pawn, so in our case, it's a character. So the controller possesses the pawn, and it also possesses the character. So now, when the controller is in the possession of the character, now this controller can actually make this character steer itself in ways that's governed by the rules that's set by the controller. So to put it in a very simple terms, I can give you an example. Like, imagine a game world where the player, when he spawns, he looks for a chopper and he runs towards the chopper. Okay, so when he runs, now even for the running animation, the controller is going to say, okay, run over, run over. Now that is just the AI controller. I'm talking about the player controller, where there's another controller that's going to be the player controller itself that will make the character run around. Okay, and after that, so, or let me just speak it out in generic controller terms, not in basis of AI or player controller. So the controller is going to be making the character run towards the chopper. Okay, once he runs towards the chopper, now the controller is still possessing the pawn or the character at this point. Okay, and then the next step is going to be the character wants to get inside the chopper, so he opens the door of the chopper, or he opens the top shield, or not the top door where it slides, which just opens up vertically, and where the player can enter inside. So he opens the door in a certain way of the chopper, and so now that chopper animation belongs to the chopper, and also the animation of the player or the character opening that door is also still possessed by the character. So now now when the character is inside the chopper and he shuts the door, now he's ready to fly. At this point, the game says, okay, now the control is going to be handed over to the chopper. Now the controller is going to depossess the character and it's going to start possessing the chopper, because the characters inside the chopper, and now the whole rules of the movement is going to be governed by the chopper, which the controller will first depossess the character before possessing the chopper. So now when the game says, okay, now when the player says, okay, let me try and fly, or let me start the engines. And when the engine starts, there's going to be something's moving, the fans and the rotor blades are going to start rotating, and there's going to be engine noise, and all of that is inside the chopper, not inside the player. The player is still sitting still inside, but now it's all the chopper that's taken over. And when he starts flying, now the chopper says, okay, now it's my turn, and I will govern the rules and I'll set the behavior of how to fly around. So that's why you separate a controller from a character or a pawn. Character is always a pawn and a pawn is always an actor. Okay, so now when we open the controller page, okay, there are simple things that we can do here. Okay, so now once inside this AI controller page, we're going to do some simple things. Go over to control. I'm going to go over to event graph, and I'm going to add some very simple code for making the barrel in the level move around. Okay, so first thing is I'll be creating a custom event. So I'll say custom event, and I'll name this wander. Okay, and what I want wander to do is every few seconds I want this barrel to move in random points that is chosen by the engine, and I just want him to move around. Okay, and so the first thing is I will look for my controlled pawn. I'm going to look for the body of the pawn or of the character. That's the first thing I'm going to do. Okay, so now that we have the controlled pawn, you still have to check whether or not it's valid. For the most part, it is going to be valid, so we'll just check is valid, and we'll use this little utility, not the function here, and it says that returns true if the object is usable, non-null, and not pending kill. Now this says determines if an object is valid, and this is not a pure function. While on the other hand, I think this would be a pure function. So if I say is valid, this would be a pure function. We don't want this, okay? And we want something which can also have a different result. It might or not. It might not even be valid. So in that case, we're going to use this. Then let's connect that. Once we connect this, and now once that's valid, what do we want to do? Now we want to move this AI. We want this component to move somewhere. So there's a nice function called AI move to. Okay, not move to actor, not simple move to, but there's a little, it says simple order for pawn with AI controller to move to a specific location. So we'll use this function, and of course we only going to run this when it's valid. And it also says world context object. I'm not really concerned about the world context object. We actually want the pawn because that is controlled pawn. We already have the controlled pawn, so we want this wire to be connected to the pawn instead of the world context object. So I'm going to hit control and I'm going to drag this over to the pawn. Okay, and now that we have this, there's another function that we can use. Now we have to give it a destination. Where do we want this little barrel to move around? Okay, there's another function called random navigable. It says, okay, so first thing is we get the actor location, right? So once we get the actor location, because right now it's just a pawn, and we actually want to get the location of where the world position of the actor itself. I'm just going to move this to the right a bit. And once I'm done with that, once I get the actor location, there's a neat little function which says get random point in navigable radius. Okay, that's a pure function again. Now this is a very useful function where it returns a random location given the radius amount. So if I say within 2000 units of radius, give me some random point in the world. So this returns the random point in the world, and of course this is a Boolean value. We don't need that. So this returns a random vector or a random position in the world in the form of a vector, and we just connect that to the destination, and that's all. So that's all this wander function does. So in a custom event, we get the control pawn and check whether it's valid or not. And if it is valid, then we have an AI move to function. And instead of having this connected to the world context object, we connect it to the pawn because that's what we want. And for the destination, we get the actor's location from the get control pawn. and then we run the simple useful function called get random point and navigable radius, and we give it a radius of 2000 units. It returns a random location for us, which gets passed into destination of this AI move function. And that's about it. It's as simple as it can get for now. Okay, so now that's this whole chunk of code just for testing purposes. And what we want here is we want this wander function to be called every 5 seconds, or a set, in regular intervals. So I'm going to pull off a wire from here, and I'm going to say set timer by event. Okay, and connect that to event pick and play, and then give it a time of say 5 seconds. So every 5 seconds, this event is going to be fired. So every 5 seconds, we want this barrel to be wandering around in the level. We want this whole thing to happen every 5 seconds. And if I check on looping, I want this. So you have to check this on looping if you want this to happen every 5 seconds within the game time. Okay. So I'm going to hit compile. I'm going to hit save. I'm going to go back to my character base, and I'm going to look for class defaults. So right now, if you look at class defaults, and if you look at these spawn settings here, we have all of these. We're not worried about this. And it says auto possess player disabled and auto possess AI placed in world. And it also defines what the AI controller class is going to be. So right now it's simple AI controller, but we don't want that. This is the default AI controller. That does not have the wonder function. In fact, what has a wonder function is the AI controller base. So you click on that and you look for the AI controller base, which is right below that. Okay, now it understands where should it take it, where should it take the AI code from, and it should be taking it from AI controller base, and then go and compile it, and it automatically saves it. Now I'll just, instead of going to play, I'll just go and simulate it and just watch this guy, let's say, move around. Okay, and there you go. So now he moves around, he finds that location, and he moves around. After the next 5 seconds, he moves around again, and this time he's just floating around in the level. That's okay, because he's still above the ground because of the capsule component. And then again, after the next 5 seconds, he goes and stands here. I'll just follow him for 3 more times just to find out that he is moving right, collisions are right, and also the positions that he's moving to sensible. So now that's a normal position, and that's a navigable place, and there you go. So he goes there. So it's because of this particular cube that we added there, he was able to take the stairs and go there instead of jumping over this wall and going there. If you are allowing the players to jump over the wall, by all means, but I did not want the players to jump over the wall and land here. So that's why I added this cube. If you want, you can take this cube off. So if you recall, from here, from this point, the barrel went here. Okay, and to go there, the easiest path is just to jump over the wall and land there, right? But he actually took the stairs and went there like a gentleman. But if you want, you can take the cubes off, and at that point he'll find the shortest possible path and you just jump over and you'll land there. That way it's the most optimal path for him, but that again depends on your design decision. For this tutorial, I thought that, okay, I don't want people to jump over the wall, so I had the cubes placed there. You might not want those cubes placed there. That's totally up to you. Okay. So, and I'm going to stop that, and this guy, I guess, is still moving around. So if I go over to the top view, and if I look at where he is, I can find him. There you go. So now you get a better view of where he's going. And there you go. And he walks around the courtyard, stops there. And again, if you want, you can hit P, and you can see the whole navigable area. And he actually walks around pretty fine, and also everything is cool. Just for 1 more minute, we'll just monitor where he walks and how he walks. And after that, we'll just shut it down. Okay, I don't know why he had to go from here, not sure. And there you go. Okay, had this cubes not been there, he would have jumped off and landed here. That's cool. I think he disappeared. Where did he go? Oh, there he is. He was below this arch. Couldn't see him. All right, great. So I'm going to stop him and I'm going to go back to my perspective view, and I'll get rid of this P, get rid of this navigation volume. And there you go. So that was the simplest AI that we ever built. Okay, so that was the simplest AI in the world. It just finds a random location in the world and it just moves there. That's it. As simple as that. But it's important that you do not forget to go to the class defaults and change this. So if you want to know what happens when I don't do that, so if I just hit compile and it already saved it, if I go back to simulate, and I can just I'll be staring at this whole day long. It's not going to move. So hasn't moved yet. See? Because it doesn't know where to get its AI code from, right? So of course, so it's very easy to forget. So make sure that every time you create a controller, AI controller, and you want any of your characters to use, you have to go over to the class defaults and select that particular code base, so that it implements the code from that particular AI controller, your own custom AI controller, instead of its own, which has no such code there. Now to just skim over this very simple thing very quickly, this is a custom function, and we get the control pawn, that is the body, not the brain. And then we check whether the body or the control pawn is valid or not. And if it is valid, then we just say, we run the function from its brain, that is the AI move to, and we just want it to move to a certain destination. And instead of this being in world context object, we want this to be in pawn because we are getting the pawn. And then for the destination, we get the actor's location, and then we use this useful function called get random point in navigable radius, and we give it a radius of 2000. And it every five and then it calculates random location within this particular radius, and it returns that, which is passed in as the destination variable for this AI move to function. And this event gets called every 5 seconds, and as soon as the game starts. And you have to check looping if you have to call this event every 5 seconds. As simple as that. Okay. So that was about this guy moving around. Pretty simple. And in the next video, we're gonna get rid of this barrel and we're gonna bring in a real character and we're gonna give it our own behavior. Okay. I'll see you in the next video. Thank you. Welcome back. So now we have this. We have a simple character which is represented by a barrel and a capsule moving around with a simple code that we wrote in the previous video. So in this video, we're gonna go ahead and change this barrel to a character. Okay, to the character of our game, a proper humanoid character. Now, if you recall in the first video, I spoken about two different assets from the marketplace that you need to download. First one is what you're looking at, all these assets that came from Infinity Blade. And then for the character, I said that you can look at the Couch Night VR demo, and even those assets are provided for free and you can use them commercially if you so like. So if you've downloaded all of that, you just need all the FBXs in that particular project. So FBXs in that project was nothing more than few characters and some textures and a bunch of different animation. Okay, so before I import the character, I'm going to set up the project structure in a way that it's systematic. So I'm going to create a new folder. I'm going to call this assets, and inside assets, I'm going to be creating a new folder called character, right? And now I'll be importing that character. Okay, so I'll just get the character in, and I'll just bring in the splayer character 2_fbx. So and just drop it in, and this is from the Couch Nights demo that's available in the marketplace. So once you bring that in, the import tool is gonna recognize the asset as a skeleton mesh. So it says skeleton mesh and an import mesh, and the skeleton which we haven't gone in yet, and you'll know why. And then I'm just gonna quickly run through all the options, and I'm gonna look at it and import animations. No, we won't. We'll separately import them. And then inside you have this. That's okay. And then if you click on this, compute normal is fine. Make T space, that's okay. So I want to bring in import materials and the textures. Now there are no textures that we're importing because it has none built inside this FBX itself, but we'll be bringing them in separately later on. So I'm just going to say import, or you can also click import all if there are more than one asset, and that's it. And it says no smoothing group and the same blah 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 message that you can ignore. And the moment you bring in the character, you'll notice that 4 assets has been downloaded at once. So you got the material, you got the player mesh itself. So if I double click on that, and so there she is. It's a girl. It's a little girl. It's a she's a night girl. And then when I go back, and then there's a physics asset that it automatically creates, the import tool, and then it also creates a skeleton based on the mesh itself. Now, physics asset, it automatically gets created by the engine, and it's not guaranteed that they'll always work. So now you can see that we're not going to be using physics assets at all in this course, but suffice to know that physics assets that is auto generated by the engine is not very reliable. So sometimes they work, sometimes they don't. Okay. So I'm going to close that and then go back here. And then this is the skeleton. And of course, this is the whole skeleton tree that you can see in the left in this panel. Okay. So now that we have that, and we also have m underscore player underscore main underscore instance. That's the name of the material that's it's named it that. So I'm going to change the name of the material to m underscore character master. Okay. And first thing is I'm going to save all before I lose anything. Okay, so now that we have this, let me also bring in all the textures. So I'm going to separate them in different folders. So first I'm going to be renaming this as, this is a skeletal mesh. So I just say sk underscore character, sk underscore night girl. She's a night girl. And then this is a physics asset. So I'm going to call this phys underscore night girl. Okay, or I can also name it as character. That's okay. She's a night girl. That's okay. And this is a this is a skeleton. So I'm going to rename this as skeleton underscore night girl. Now, a skeleton is what the animations are based on, and we haven't imported the animations, so we'll do that separately because it's not really baked into the FVX. The animations all separate animation files. So we'll bring them in later on when we need them. Okay, for now, I'm going to rearrange them in their own structures in the own folder. So that was the character, and this will be the materials. Okay, and then I'll create another folder called textures. Okay, then I'll create another folder called skeletons. Okay, and then say skeletons and physics asset. Okay, and this will be the meshes. Okay, all right. And so the materials will go inside material and move here, and the mesh will stay there. Physics night girl and the skeleton will go inside here. Okay, and move here, right? So, and then we are going to bring in the texture. So let me go back to the folder, and I'm going to bring in t underscore player underscore d, diffuse, the mask, and the normal. And I'm going to go back and drop them inside Unreal. And it says was imported as a normal map. No, I don't want to revert. I shouldn't have done that. I said delete. Go back here and just bring in the normal. Yes, it is a normal map. I'm gonna save this right away. And this says t underscore player underscore d, which is the diffuse texture. This is the player mask, and you'll know why this is the whole texture. And then this is the mask, and you'll know why it's a mask. And then as we are writing the material code, it'll get clear why a mask is going to be used. And then this is the normal map of the texture. Okay, and then we have that. So now I'm going to go back and I'm going to create a very simple material for this girl. She's a girl. So I'm going to go back here, and first thing is I will bring this guy here, and I'll hit delete because that's the default thing, and I don't need this. In fact, I need textures. Okay, so first thing is I'm going to bring in a texture because I do not want that base color vector parameter. I'm going to bring in a texture. We already have a texture. So I'm going to click on textures. I'm going to click on t underscore play underscore d, come back to material, and I'm going to say t. And once I do that, this automatically gets applied because I had that selected. Okay, and now I'll just click on the base color. I just connect the base color with the main color, and then you can see that this words come up. But of course, you can't really make out what your character looks like on a sphere because a sphere is not your character. So a good way for doing that is to bring in your character here is to go back to your content browser and look for your character. So it's there inside the meshes. Click on the sk underscore night girl, come back to the material and click on this little teapot. So now you can see your little character. Okay, now she's there, and also the texture has been applied. Okay, now that's just a basic thing, and of course you can bring in the light out here on the front like this. So now you can know what she looks like. Of course, it's got no depth and it's just plain diffuse color. So now if I scroll over here, I just bring in the normal map. So going back to content browser, I'll go back to my textures, click on normal map here. Inside the material, I'm going to hit T again, and that should fill it up with the normal map. Now, of course, the normal map connects with the normal map like this, and wait for half a minute or so, and now you can see that normal map has been applied. Of course, this is not the only thing we're going to do. All looking nice and dandy, but let's do something more. Okay, so we have this. Of course, we can go ahead and do more of advanced stuff here right now, like setting up the mask and changing the hair color and all that, but I won't do that just yet. So instead, what I'll do is I'll save this material, and I'll go back to my, once it's saved, go back to my character base, and I'll set this up before doing anything else. So I'll click on this barrel, I'll delete, and so the static mesh component is gone. Now I'm going to select the mesh. I'm going to look for the skeletal mesh. Of course, you can look for it here. If I click that, there are 3 skeletal meshes in total. So the first 2 came in by default, and this is what we're looking for, SK Night Girl, and there she is. So she's now standing there with sort of like a T-pose, half T-pose or whatever you want to call it. Now, a couple of things wrong with her. First, she's way above the height, or she's going beyond the capsule, and she's also too high in the capsule, and she's also not facing the right direction. So the first thing is I'm going to select her. I'm going to make her stand at the base, or maybe first I'll rotate her 90 degrees, 50, 60, 70, 80, and 90. And now she's looking at the right direction. She's facing the arrow. And next up, I will select the capsule component, and I'll bring this down to 70 because the capsule height is too big. Now I'll select her again and bring her down, not too high. I'll bring it down by 50 centimeters, like that. I think she's not yet at the base, so I'll bring it down by 10. One more. There you go. I think one more is good. There you go. So now she's standing at the base, and she's also got that nice height there. Okay, so I'm going to hit compile. I'm going to save. I'm going to look at the main arena, and there she is standing. And now let's just simulate it quickly, and let's see things are working and nothing is broken. Okay, I'm just going to hit simulate, and I'm going to follow her if she's moving now. And there she moves. Now, of course, she is moving like that Ghost and Exorcist movie. There are no animations. Of course, we'll have to fix that, but that's okay. There she is, and she's going around there. I'm going to follow her for like a minute more and just check that everything is fine. She's not doing anything funny with the collisions. And she's going back there. And let me see. And I want to see what she looks like against the fountain. She moved back again. So I think she's okay. So the next thing, of course, is bringing in the animations. And before the animations, we also have to, enhance the materials a little bit. So did she move inside? Oh, she moved inside. That's strange. So I was actually wondering if I bring in the P again, and there it is. That's the reason she moved inside. That's a very rare bug that she can't. Oh, there it is. There it is. That's why she moved inside. So this was selected as a random location. That's why. Okay. And of course, if I bring this up again, just bring this back, and I do that. Nope. I'll just hit Control Z. I'll stop first and select this guy, and then move him up like that. Okay, and I just want to make sure that that's because this is hollow. I think it says visible. If I go over to my content browser and check where he is, and does he even have collision? Simple collision, that's not good enough. So what I'm going to do is I'm going to go back to, I'll just hit apply and go over to simple collision. So I'm going to click on, let's say, let me just go to wireframe, and let me click on simple collision, complex collision. Nope. So let me go back to my lit mode and increase this by 32. apply. There it is. Just hit delete. Let me turn on simple collision, complex collision. I think this whole rock something else totally. So what I'm going to do is I'm going to look for other rocks like this. If I click on that and come here, if I go to simple collision, I can barely see it. So I can do this, go back to my main arena. I think this is it. Go back here, and first is I'll go to collision and I'll say there's no collision at all. If I just say auto convex collision, and if I go to there and accuracy is that, and apply again, go to collision, there's no collision again. Okay, if I say add walk simplified collision, so that's one possible way. I think that's okay. And if I say simple collision, that's the simple collision. I just hit save and I'll go back here and let's see what happens. Okay, and I hope it does not go inside now. It's still there. Let's see if I click on this and if I move this up a little bit, or if I move this down like this. That's because if I do that, very strange. Should be a bug. Okay, can't help that. Very during rare occasions, she's gonna go inside, and again, Control Z, bring him back down there, Control Z. Okay, that's okay. I think I'm gonna keep it there, and even if she doesn't go there, it's okay. Or again, if I want to, I can have another box there. Let's say a box. Okay, and rotate it a little bit. Just stretch it around, and put it in here. Okay, and of course, maybe put it up. It's already going in there, can't help it. If you want, we can have another cylinder there. Okay, and simply rotate it like this, 90 degrees. This, just scale it up and move it here like this. Okay, and of course that area is taking it up. Okay, I think that should be okay, or even just need not be there. Let her walk there. I mean, that's a very rare bug. I'm gonna quit tweaking that around. But anyways, going back to my character master, I'm gonna set this material up to be a little more dynamic in nature. So what we're going to do here is we just have one character in the game. So we're going to be setting this up, the same character as also the enemy. And we will differentiate the enemies from the player character using the hairstyle. Okay, so right now she's got brown hair color. And we can set up something else which is also there for the enemies. And we'll use the same character and the same material for them as well. Okay, so how do we get that mask thing done? Now, this is actually the topic of masking. So what I'm going to do here is I'm going to make some space for myself first. Go back to the content browser and click on the asset inside the textures. I'm going to select this first, come back to my material, hit T so that that gets selected, hit T and do that so that it comes along with the mask texture in. And then I can first, for now, I'll just connect it to the base color. But before that, I'll just show you what this mask is. So if I double click on that, double click on the mask texture, and I just look at the green channel. So this is what it looks like, and this is what the red and green looks like, blue and alpha. So I'll close this and I'll show this in detail. So if I connect this to the base color, that's better understood by looking at this. Now just wait for, yeah, there you go. So if you look at this carefully, wherever it's green, it's a hair, okay, and wherever it's blue, that's her eyes, wherever it's black, that's her skin sort of, and wherever it's red is her armor or the clothes or whatever you want to call it. Okay, so what we are interested in is her hair. That is the green part right here. So we can use the green channel to our, to our benefits. And so if I bring out the green channel, and I'll just close this for now, and if I bring out the green channel and I just say lerp, so you can just lerp or L and click on lerp. So the green channel goes into alpha, okay, and of course this goes into the base color, and let me show you what this looks like. If I have to preview this, there you go. So just give it a minute. So there you go. So now I'm actually only getting the hair off from that mask, and I'm lerping it between 0 and 1. So I want to say whenever there is white in the texture, or whenever there is this particular or these kind of pixels in the texture, I want to change the color for that. Okay, so now I'm gonna bring in the texture sample. I'll be pulling out a wire from the green channel, and I'll just type in blend overlay. Okay, and blend overlay, what it does, it takes in two different entities or inputs coming in from different places, and it blends it, as simple as that. So this is a quite popular technique in Photoshop. And now once I have that, I'm going to hold down V, and I'm going to bring in a vector parameter, and I'm going to call this color. Oh, did I do something? Okay, I just type in color. There you go. Okay, so first is I'm going to be connecting this over here. Okay, and of course it's still white, and let me give this a color. I'm going to give this a nice brown color as the default. Of course, you can change that, something like this, like that. Okay, and then this connects to B. Okay, right, and I'm going to stop previewing that. And now if I look at it, she is going to be looking all okay. And of course, the lerp also has to be connected to the base color coming in from the texture itself. So you are lerping the UVs to the blend overlay results of the green channel and the color parameter, right? So now she has a brown color, and now she looks good. Now, if I change this, if I have to have a different enemy, let's say I want to have a red one, and you can watch that change in real time. And it's not yet. Maybe maybe this is good. I can have her blue and just wait for a while, and there she's in blue, and have her in green, and there she's in green, have her in yellow. Okay, and that's not yellow, just this yellow. Okay, all right, that's because it's blending between the two colors. It's not exactly that color. So I'm just gonna go back and put her and give her some normal basic color, and that should do for now. So I'll just hit OK, and we have our base material. We also have a base character with the base material setup. So I'm going to hit save, and I'm just going to take a look at what she looks like in the game. So that's done, and if I look at, go all the way there where she's standing, and there she has blue hair. Okay, of course we can keep on changing that. So maybe for enemies you can have red hair or something else, just to depict that it's a different character, because we are using the same character. So we will be differentiating it through the hair colors inside the texture, inside the material. Okay, so we have the basics covered for the character. We have her imported. We had it imported, got her set up inside a character blueprint, and we have also given her basic behavior as an AI for just wandering around every 5 seconds to random locations. And then we have also set up the materials with masks built in. Instead of color, I'm going to call this hair color. Okay, and then we also have given her different hair colors. I mean, a material which has the ability to change the hair colors. Okay, and I'm going to hit save and go back and save all. And when we return in the next video, we're going to be importing in all the animations for her, and then we'll start making her move around with animations, attacking her. I mean, attacking other characters, getting attacked, and taking damage and stuff like that. Okay, I'll see you in the next video. Thank you. Welcome back. So what we have now is we have this basic character with the material set up, and all the textures also imported in for the character. So the next thing, obviously, we know that we have to make her animate. Okay, we have to animate this girl. So for that, I'm going to create a new folder called animations, right? And just check that we have everything here. We have the material, you have the mesh, of course, which is standing here, and we have the skeleton and the physics asset, which is not going to be used, but it just gets made automatically when you're importing a skeleton mesh. And this is extremely important, without which we cannot have our animations going, because animations all reside on the skeleton. And then we have the texture. Okay, so now for the animations, I'm going to bring in all the animations. I'm going to bring in all the player underscore animations along with swing 1, swing 2, and the victory. And I'm just going to drop it inside here. Okay, once I do that, if you notice, if you're bringing in skeletal animations, then it's going to ask you which skeleton do you want to apply it for. Okay, and I'm just going to say click on this, and we just have two skeletons. We have one for this, which probably came in by default, and then we have the skeleton night girl that we just saw, that we just renamed. Okay, and I'm going to go skeleton night girl, and if I look down here, and it does not need any materials or anything, so I'm just going to say import all, and it's going to import everything, right? And just wait for less than a minute, and there you go. Now I'll save all, and all of these animation sequences along with the levels. So I'm going to say yes, go ahead, save them all, just so that you don't lose anything. And there we are, we have all the animation. Okay, so now that we have all the animations, it's always a good habit to actually check out all the animations whether they're playing or not. So this is player attack, that's fine. And then go back here and player attack 2, that's reverse sweep. Then player attack blocked. Okay, and then just double click on every animation and make sure that it plays. And then again do that, that's player block recoil. Okay, and do that. This is death, player death, and falling. Okay, when she's falling from a high place somewhere, and that's falling attack. Okay, and then just go on clicking on every single animation, and she's flinching fine. So all of these are going to be used by us, at least most of them. That's flinch small. Okay, and then got this, and this is simply idle. And if you look at this, idle is actually nothing. She's just standing there, and I believe she's even moving, but that's the animation. So that's why it's important that you take a look at what the animation is. And this animation is actually playing, but this is what this animation is. She's not actually moving at all. In fact, while there should be something which makes a move. So this is idle start. So this is something idle, and she's starting off to be in an idle state, and then she goes on in a relaxed mode, and so on. This is jump backwards. Okay, that's all of that is going to be blended well, and this is going to be jump forward. Then you have the jump left. Okay, and then you have the jump right. You have the jump up. You got the land. You have the land attack. All decent animations. All of these animations are coming for free, so it's really good. And this is something that we'll be using. And then player run backwards, also pretty cool. Then player run forward, player run left, that's actually strafe and run, strafe and run right. And then you have shoot. Okay, that's for shooting the magic projectile. And then when you're sprinting with the sword behind you, then you got the sprint attack. So you come running in and you attack the enemy with a sword. Then swing 1. Okay, that's like forward swing, and then swing to end is going to be backward swing. So the combination of that is going to be a full swing. Okay, and then the final one is the victory, and woohoo, she's happy, right? So we have all of these animations set up, which is pretty cool. Now there's there and Unreal has two different concepts when it comes to animations. First, you have animation sequences, like what we just saw. All of these animations are animation sequences. And second, we have something called a montage. Unreal has something called a montage. A montage is a level above the simple animation sequences, like these individual files, wherein it has a completely different layer of information on that particular animation, like notifiers and so on. So a montage is what it takes an animation and it processes it in a certain way to make it more informative for the engine. That's what the montage is. Well, what we are looking at right now are all animation sequences. So we will be working with montages, don't worry. So that was the basic difference between animations and montages. Okay, so that was about animations and animation montage. So I'm going to do something now. I'm gonna right click on animations. I'm gonna click a new folder. Inside that, I'm gonna call this blueprints, because blueprints is not just confined to your normal code. It also has, there's also something called animation blueprint, where you can regulate the behavior or of animations, make state machines on them inside animation blueprints. So I'm gonna right click and I'm gonna create a new animation blueprint. These are all the things that you can create in animation, and go back here and click on animation blueprint, and it's going to ask you what skeleton do you want to base it off. So we want the skeleton knight, and so I'll just say okay, and I have to name this. I'll say ab underscore knight girl. Okay, and then once I'm going to close this off, I don't need this. And air controller base, that's okay. Character base, that should be fine as well. Click save the map, and right, and I'll just double click on that. So the moment you open the animation blueprint, this is what it's going to look like. Okay, so like most blueprint editors or even the material editor, where you have something which is the final, so this can be, this can be readily compared against the material editor, where you have all the material attributes, that's the final result. So this is something like that. This says the final animation pose, and this, anything that plugs into this result governs the behavior of this particular animation or of this particular blueprint. Okay, so in other words, it's actually really difficult to explain that in theory. When you watch me do that and when you're doing it yourself is when you'll understand what this is all about. So there are a lot of things that can be plugged into this. We're going to be plugging in state machines. Now, state machines is a concept where, different states are defined and they're classified, and also the switch between one state to another and the transition and the way it blends is all defined by the user. Okay, so that's what a state machine is. So without further ado, I'm just going to add a new state machine here. So it says add new state machine, and of course the name of the state machine will be locomotion. Okay, so once we plug this into the result, okay, we have this. So we have whatever we have inside the state machine coming into the result, as that's going to be the final animation pose that is going to be shown to the user. This is how it can be seen. So when you double click on that, we have entered the locomotion state machine, and there are a bunch of things we can do right now. So at this point, now we know that we are inside the locomotion state. So what this is, the way this is going to work is, we're going to set up different animations, and then we're going to set up the rules between the transition that's going to happen between the animations. So what I mean by that is, if I pull out a wire from here and I say add state, and I give this a name called movement. Okay, so I'm going to move. This is my first state. I'm in movement. This character is in movement. Now, what all things can I do when I'm in movement? So first, I can obviously move. That's a normal movement. And then I can jump. Okay, so if I pull out another wire from here and I add another state and I call this jump start. So what this means is I'm about to start jumping, where my knees are bending and I'm about to just jump. Okay, and when I'm about to jump, what happens next? I'm in the jump state and I'm somewhere in, let's say I add another state and I say jump mid. So I'm somewhere in mid air, like I've already jumped, the jump has already been initiated. Now I'm kind of in mid air while my hands are flailing sort of, and then I'm in the jump state and I'm about to land. So which means there should be another state called land, okay, or landing. Okay, so this is what we have. So we have movement, and while we are moving we can jump, and the jump is now divided into these three sections, and after we land we can go back to our normal movement state. So this is what the state machine looks like. So this is a cycle sort of, and so, and if I just rearrange that so that it looks neat, and of course I can rearrange this to have that here so that it looks symmetrical sort of. So let me explain this again. So we are inside the blueprint, AB Night Girl, and this is going to be the final animation pose. So anything that gets plugged into this result determines the final behavior or the final animation that's going to be shown to the player out here, right? And so we create a new state machine. A bunch of things can be plugged in as a result for this final animation pose, but we created a state machine because we want to have a state machine. So we created a state machine called locomotion, and inside the locomotion, the moment it enters, it's going to start moving. The first state is going to be move. And after movement, you can have a jump state where the player wants to jump up in the air. So he's just about to jump. So the knees bend and all that jump, about to jump phase begins. And then when the jump has already begun, he or she is in mid-air. This character, she's in mid-air. So that would be the jump mid. And then after that's done, the gravity is going to pull her down and she's going to come back and land on the ground. So that would be the landing state. And once she's landed, and she can go back to movement, and this will keep on going as a cycle. Okay, so we have this one way, transition defined here. So from movement it goes to jump start, and from jump start it goes to jump mid, from jump mid it goes to landing, and from landing it goes back to movement. Now now these can be two ways as well. This can be a movement to jump start, and this can come back as well. So I can pull out an arrow and put that in here. Now we don't need that. So, but this can be bidirectional, just so that you know. So you have a state. There might be requirements where you are going to a state and you're coming back, something like an attack and coming back or something like that. But we don't need that in here. So I'm going to click on this and I'm going to hit delete. Okay. So right now it's movement, jump start, jump mid, landing, and movement back to movement after it enters. Okay. So now I'm going to double click on movement and go back inside and go inside this movement state. So here it says movement state. And this is all these breadcrumbs. These are called breadcrumbs. Can move back and forth. So if I hit on locomotion, it comes back here. When I click on anim graph, it comes here. And of course, you might not have a bunch of things. So I don't think you can have one more state machine or something. This just can't have one state machine that's connected to this. That's okay. And then again, when you click on locomotion, and it goes inside locomotion, click on movement, it goes inside the movement state. So this is what you have. And this is very similar to what you see in the anim graph, where you have the final animation pose, and then you have a result, incoming pin, and things join into that to form a result. Okay, so going back here, and that's movement. So let's focus on this thing here. So when it comes to movement, there are few things that automatically crops into mind. Like, you want the player to move forward. Okay, like there are four directions, and of course there are four directions, and there are diagonal directions as well. I mean, directions with an angle with the origin. So the basic directions in this case, like, she can move forward, she can move backward, she can move left, and she can move right. So these are the four movement possibilities that we have in our game. Okay, and so what this animation, or what the state is going to do, is figure out how fast she has to move depending on, or which animation should play depending on the speed of her movement. So if she is moving really fast, then you have to play the sprint animation. If she is moving normal, if she's simply like brisking, then it would be a blend between her walking and her running, and there will be some state in the middle, and that's how she's gonna play. And if you are gonna move, if you're gonna move really fast to the forward, to the forward direction, and then start moving her to the right, then she's gonna move in that way. So what I exactly mean here is, if you want to have a character and a top-down character move forward, that character would be moving forward. While the character is moving forward, you want that character to strafe to the right or the left. You won't have a different animation. What you have to do is, you won't have a different animation for that particular angle of movement. You just have a generic move forward animation. You'll have a move strafe to the left and right, or move to the backward, and you'll blend between the move forward and the strafe right animation. And you just let the engine figure that out. So you take these two animations, put them inside this particular state machine, and depending on the speed of the character itself, you let the engine figure out how do you want to blend that animation. Okay, so again, like I said, these things are really difficult to explain in theory. So when you watch me do that, and when you imitate me, or when you just follow me, then you're going to get it really well. Okay, so how do we do that? What do I just spoke about? Now, you can't do that inside the state machine just yet. But you can only figure out the animations and all that. But if you have to blend the two animations together, you can't do that inside the state machine or the blueprint, but you have to use something called a blend space. Now, what I mean by that is, I'll go back here, and when I right click, first I'll save all, save selected. Okay, and when I come back here, it's not compiled yet. Okay, so I right click and I go to animation and I create a blend space. So you have blend space and you have blend space 1D. We're going to be using blend space. So I'll click on blend space and I'll just select it'll ask me to pick the skeleton that I want to blend, and I'll just select the skeleton night curl, and I'll call this movement blend space. Okay, and when I click that, so this opens up in a new editor with this little graph, which is incredibly useful, and an asset browser with all the animations listed here, and the animation slot manager, and the details of every single animation. So if I click on this, not click on this, but something else that might have details, maybe skeleton tree. So if I click on this, and you can see the details out here. So that's what this is. And if I click on root, and that's what this is. So coming back here, and this is asset details, and you can do a bunch of things here. And you have axis settings, horizontal settings, vertical settings. So you can tweak the name of the axis. You can set up the grid values and everything, and that will be reflected here. And this is where you create the animation blend. Okay, so first things first, let's set up this graph. Out here it says none, none, 0 to 100, and 0 to 100. So what this depicts is what on a scale of anything like a velocity or speed will this graph have animations that can be blended. Now this space or this graph, you can have animations dragged and dropped inside the space to create the blend spaces. Now again, I won't bother explaining that in theory because that further confuses people more than making them understand. So I'll just show you how this is done. So at this axis settings to the left, the asset details, let's first change the parameters for the graph. Okay, I'll just label or just change the label of the graph. So I'm going to say for the horizontal axis, I'm going to call this right movement. Okay, and the minimum axis value will be negative 200. So which means it's a speed of negative 200 to a maximum speed of positive 200. Okay, and so now we can see that this got the right movement and minus 200 all the way down to 200. So this should be minus 200 and 0 and 200. And we do the same thing for the vertical axis, and this will be the forward movement, and again this will be minus 200 to 200. Okay, so it's pretty simple. Anything that is right, that will be on this side. So if you take this character and if you literally make her move to the right, this will be on this side of the graph. If you make her move to the left, this will be on this side of the graph. So we'll make use of the same axes for making her move both right and left, right? So it is pretty much like the input settings. So if you go to project settings and inside input, and if I create an action mapping for, or an axis mapping for, let's say, move right, I guess. And then if I say, let's say I use my mouse, okay, and I say mouse X, okay, and I say mouse X, and the scale is 1. And of course, I can say, then I can say mouse, I don't need that. But if the scale is 1, okay, and a scale of -1 would be move left, and that's understood by the engine itself. So that's what even this means. Okay, so anything that is above 200, either in forward or on right, is either forward or right respectively, or anything that's below 200, either forward or on right movement, is either back or left respectively. Okay, simple. And also I'm going to change the number of grid divisions to 8 each. 8 and 8 here. Okay, so now we have quite a lot of things set up, and of course I can say show triangulation, I can say show animation names. So when we drop in animations, it's going to have the names, and this is fit grid to the largest axis. And this is the preview value, and it says hold shift to move. So if you move your cursor about this, and if you hit shift, and it gets ready to move, and it says hold control for weight details, and if I hit control, then it says right movement is 51, and now you can see that where exactly you want to move. So now if I say my forward movement is -7, this is 200 is the right movement, and -198 is the forward movement, and this is going to be full speed towards the right and full speed towards the front. So that's a perfect blend between forward and right, so that if you have to geometrically put that somewhere in a rectangle, that would be diagonally or to the top right corner from the center. Okay, again I'll just put that in the center, and this is a 0, 0 and 2, I think. Okay, so now let's start dropping the animation. So right now she's not animating, she's just standing in normal T pose. So let's take the first scenario. She is sprinting at full speed forward, okay, in this direction, in the forward. So there is something called player sprint in the asset browser. I'm going to drag that. I'm going to drop it inside here. Okay. And now if I hit shift and just watch this, okay, now it's not going to happen because we just have one animation. And regardless of what you do, she's going to be playing it that way. And of course, if I hold shift and this is the 0, I'm just going to place it somewhere. That's just a preview cursor. And now she's sprinting regardless because there are no other animations to blend. Now she's not going to start off sprinting. She's going to start off from an idle state. So somewhere halfway down. So this is between 0 and 200. So between the halfway down or minus 200, 200 somewhere in this mark, this is 0th mark, she's going to be standing idle, right? So I'm going to bring in the idle relaxed. Okay, and this is idle relaxed. I'm going to bring in and drop it here. Okay, so now if I bring this in and I, let's say, I move this, and you can see that as I move this cursor towards player sprint, she is picking up speed and she's sprinting like crazy, right? And then she's slowing down and then she comes back to her relaxed mode. And then again, I do that and she started to walk and she's picking up and fine bones and everything. Now she's going to bend over a little bit and now she's at full speed and she's charging. Okay, so that's how you blend things. Now of course, somewhere halfway down the mark, it's not going to be nothing. And so what we do is we can bring in our normal run forward and drop it somewhere here. Okay, now if I, let's say, and she's relaxed and she's running forward. Now this is forward, and then she picks up speed and she starts sprinting. Now this is little more smoother, way more smoother than what it was. If you didn't have run forward, then she was looking kind of funny. Now at least now she's got a normal running animation, and then all of a sudden she picks up speed and she starts sprinting like crazy. Okay. Okay, so now that we have this, now she's moving, she's idle, she's running forward, and she's also sprinting. Now, there are other animations that we have to take into account. Now, this is right movement, so let's look at run right and just drop it here. And now it's forming this triangle, right? So again, I bring in this preview marker and I come here and she's relaxed. Okay, and she's running forward. And now if I want to run right, then if I move my preview marker all the way to this place, and you can see that she is trying to run right. Okay, in fact, there's nothing called, does she have anything called run right? No, she just has run right and run left, I guess. And this is jump right. If I just type in right, so she just has jump right and run right. Okay, we're fine. All right, and then that is run right. Then we also have run left. So we drop her to the run left. And now again, when we bring in the marker, we making a sprint. And now at the same time, we want her to slow down and strafe out to the left a little bit. And then if you want to run, then she's going to run again. Now this is not the best scenario. We have this run right, we have this run left, but what if we want somewhere in the center here, like, she's running at the same time, we're gonna have one more blend. What if she's running right now? Okay, but before that, I'll just drop in the run backwards, and there's the run backward, and we'll put that in here. So she runs backward, and again she idle relax, and then she runs backward, and then from backward she runs right, and then she sprints to the front, then she again runs forward, then she's relaxed, then she runs left, and multiple combinations out there. Okay, and of course you can have, there's no sprint backwards. Of course, you just have one sprint, nobody can sprint backward. That's why we have the sprint run backward out here. Okay, and we can also have the run right and the run left out here somewhere. So let's bring in the run right and put that in here, and let's bring in the run left and put that in here. So now you can look at the triangulation, and if I hit shift and shift again, and now she's sprinting at the same time she's running right. Okay, and again she's sprinting, and now she is running to the right, and this should be run left. In fact, click on this and double click that, think delete. They should be run left like this, and that's okay. Click on here, right? And now she's running left, and she's sprinting, and she's running right. She's running forward. She's idle. And if you click on that, you can also see if you hit Control, then you can also see that the right movement is all of that. The player run right is this, the player run forward is that, and everything, all the information can be seen. Okay, and again I click here so that that can go away, and this will, if you toggle between this will not show the animation name, but this will show the animation names, and show triangulation, you can get rid of that, but this is quite kind of useful. Okay, the triangulation is kind of useful. Okay, and let me just preview this one more time because I'm not really convinced here. She's printing and she's looking odd here. She's also looking odd here. So why don't I just grab this and just drop it one cell below like that. Drop this again to one cell below like that. And then again, when I hit shift and click here, and now she's fine. She's printing and the velocity has come down, and also the run left, because you can't have the same velocity or the same speed for the player who's sprinting forward, and the same velocity cannot apply for running left and strafing uh, on either directions. Okay, so now I can just make her run right. This is run right. Okay, and of course when she's idle and she's not, this is simple speed based on speed. This, she's running right and she's running left. And again, while she's running, and if she brings her speed down, she can have one more run right and one more run left. And then she also runs forward and she runs backward. Okay, great. So with that blend space, simple blend space setup, I'm just going to hit save. I'm going to go back to my animation blueprint, and out here, inside here, I'm going to look for blend space, and out here it says blend space player movement blend space, the one that we just created. So once I bring that in and connect that and I hit compile, it's going to give me a compile warning. That's okay. And it says movement to jump start will never be taken. Please connect something to can enter transition. That's okay. We won't worry about that. It says fast path enabled. This node is not using any blueprint calls to update its data. That's because it's not really updating its data and it's not being referred to outside of this animation state at all. But that's where the event graph is going to come in, because right now it does not have the values for the right movement and the forward movement, so it doesn't know what to do with the animation. So this is where the event graph comes in, and we're going to set up our logic out here. Okay, so inside the event or inside event graph. Now this is just like any other blueprint, so we can have variables set up. So I'm going to create a new variable first, and I'm going to call this total, not total, local velocity, and this is going to be a vector, right? And we're going to be using this update animation node. So much like the normal blueprint where you have the tick function, the event blueprint or the animation blueprint uses something called an update animation. Okay, so the first thing is I'm going to get the pawn owner. So I'm going to say try get pawn owner. I'm going to say if I'm going to check whether this even has a pawn. Okay, so once this function runs, and we also have to check whether it's valid. So we'll say is valid, and we'll get this function which has pins in it, non-impure function. And then if it's valid, if there's a pawn that is valid, what we want to do is we want to set up the velocity. So I'm going to hit alt and I'm going to bring in the local velocity, and I want to set this. Okay, and so how do we set the local velocity? The first thing is we get the velocity from the spawn. So we just say get velocity. Okay, now unfortunately this function will return the velocity in world space and not in local space. Okay, so for how do we translate, how do we convert, the world space velocity or anything that's in world space to local space is there's a function, if you recall, in one of the earlier courses in pinball, we use something called inverse transform direction. So this, what this does is takes in a transform and it converts the world transform into local transform, and then it gives you a direction, and that turns into, that is what gets plugged into this as the local velocity. Now where do we get the transform from? We get the transform from the actor, and we already have the pawn, so now we can just say get actor transform, and this transform gets plugged into this, And now this returns a value which is in local space, and that can get into local velocity as a local velocity. Okay, and then when I hit compile, and then it goes in there and it does all of those things. Okay, so if I hit compile and save as well, so first thing is I'm going to go on success only. Okay, all right, fine. So, and if you're wondering what these warnings are, this is actually warnings for the jump start state and the jump mid and landing, which hasn't been set. That will be set with time, so don't worry. So you can ignore these warnings for now. Now, going back to the movement state, out here, it's got the right movement and the forward movement, which is still sitting there all by itself, doesn't know what value to be entered. So we drag the local velocity and we get it. Okay. And once we get the local velocity, we right click and we can say split struct pin. Now, in Unreal, X is forward, Y is sideways, and Z is upwards, right? So we can just set that pin up for X as forward and for Y as right. Okay, and then I hit compile, and of course it's not gonna show us anything because still the local velocity is at 0, 0, 0. So if you want, you can test it out right here, but and quickly, once we just run a simple test, we're gonna stop and we're gonna go over to our locomotion, and we're gonna start working on our other states. So let's see, if I say 200, that's 200 to the X, and she's sprinting already. Okay, and if I say 15, and she's normal walking, right? And she's walking baby step. Okay, and of course, when I say, let's say 80, and she should be sprinting to the right. They're not sprinting, but moving to the right. And if I say 200, she's gonna be sprinting towards the right. I mean, even though she looks ridiculous, but it's okay. But that's how she strafes to the right in a high speed. And there's nothing called Z. So if I can also give in negative values to test it out. So I think this should be 0. And if I want to see her move backwards, then I can say minus 150, and there you can see her moving backwards, right? So that's it. And compile, save that, and then you can go back to locomotion. Okay, so check everything is working. So inside movement, and when you click on the movement, this thing has been set up. The local velocity is 0, I hope. Yes, and this is also going in, and movement blend space, and that's movement blend space. And of course, I should get the strangulation and everything showing. Okay, and hit save, and then I close that and come back here. And then when I go back to my character base, when I click on my character base, and when I look at my mesh, and when I look at the animation, she's right now using no animation class, and it says use animation blueprint. And if you recall that I said, I think, is she right on the bottom of that capsule? I think she's fine. So if you click on this anim class drop down, you can see our AB underscore night girl, which is an animation blueprint. Okay, so now when I select that and when I hit compile, okay, now she's automatically changed pose because that's the basic pose that she gets into. Okay, and then I click on simulate again. Now let's watch her walk around. Okay, and she walks around. Now you can see that she's running, and there you can see she's running, and she'll strafe if she has to. Okay, she's not strafing. It's hard to say whether she's strafing or not because it depends on where she's going, and that's her normal idle state. And there she is running, and I don't know, she's strafing. I don't think she's strafing because she doesn't have to, and it's really hard to figure out where did she go. Where did she go? I lost her. Did she go out somewhere? Oh, there she is. Okay, did something go wrong? I'd lost her somewhere out here, and oh, there she is. Oh, actually, she ran back. That's why I couldn't figure out. She turned around and ran away, and there she is. And then she's running again, and now she'll run again. So I hit P, and let's see how she runs. I don't know where she's going. Now she's running again. There you go. Okay, okay, great. So she's doing the running animation. Hard to say whether she's strafing because she doesn't have those. It's really hard to test that out. We'll test it out once we set up an input and once we start hitting the keys, and we can easily figure that out whether she's strafing or not. But she should definitely strafe if she has to, but can't force her to. That's great. So she's doing the running animation, and that's about it. And I think no, she wasn't strafing, but she was just sliding, and that's another bug. But we'll figure that out later. Okay, so we have all of this set up. So just to rephrase, we created this little. We first created our animation blueprint, and we went on to the anim graph. We created a state machine because we know that anything that plugs into this is the final animation pose that is shown to the user. So we first created a state machine and we created 4 different states: the movement, and then the jump start, and the jump mid, the landing, and then which comes back to movement. Now inside the movement, we created a local velocity variable. Okay, and this comes in from the blend space that we created. That's called the movement blend space. We double click on that, it takes you to the blend space, and when you triangulate all the states on or animations on, and you show the animation names, you can see that all of these states are set up in this fashion where it's blending perfectly well. So, and then after that, this gets plugged into the final animation pose, and this is coming in from event graph. So first we get the pawn owner and we check whether it's valid or not. And if it is valid, then we try and set the local velocity. And for the local velocity, we get the velocity of the pawn that she's moving in, and then we convert it from world space to local space using inverse transform direction. And the transform is coming in from the get active transform function that gets returned to the local velocity, which gets set up with the local vector, local velocity, or the velocity in local space. Okay, and then going back to movement, we simply set up the x variable, x component of the local velocity vector to forward movement, and the right velocity of, that is the y component of the local velocity vector, to the right movement in the movement blend space, and that gets blended, and this in turn comes back here, and that's what happens. And this is what we have right now. Okay, so that's about it. That's about it for this chapter. And in the next video, we will start setting up her jump animations. Okay, I'll see you in the next video. Welcome back. So now we have, the player animations, at least the forward movement, forward animation set up for her. First thing I'm going to do is I'm going to rotate her somewhere here to move this way. Okay, and that's it. It just was bothering me because she was facing this direction. But anyways, so we have her moving around now, but we don't have anything that's jump, right? So we'll go ahead and set up the jump animation right now. And just bear this in mind that for the jump animation that we'll be setting up, there will be no way for us to test it out like we were able to test out the, the move forward, the move backward, or all the movement animations by just simply tweaking the values inside the local velocity variable inside the blueprint. You won't be able to you won't be able to test the jump in that way. But after we set up the player controller with all the input bindings, then we'll be able to set up the jump without any issues. So for setting up the jump, of course, we go back into our locomotion and state machine, and then the transition, this is the transition between movement and jump. So if you recall, we created this whole graph just as a way of showing transitions between the different states. So from movement, it's going to go to jump start. From jump start, it's going to go to jump mid. From jump mid, it's going to go to landing. And from landing, it's going to come back to movement. So on entry, movement is going to be the default state. Now for this transition, you have this little button here, or you have this little icon which says, it doesn't say anything, but it just denotes transition from one state to another. So when you double click on this, it's going to bring us to this particular graph. Okay, and there's a boolean which says can enter transition. When this is checked to be true, it means that this can enter transition. So how do we set up the jump animation? It's quite straightforward again. So we double click on that and let's get started here. Okay, so that's pretty simple. So the first thing is we get the pawn owner. So we say try get the pawn owner. So once we get the pawn owner, so we first check whether it's valid, or I think we can. We say it's valid. Okay, and or actually we don't need that. Yeah, we don't need that. So we'll get the pawn owner, and then we will get the movement component of the pawn. Okay, and then we check whether the pawn is falling. So we say is falling. So that's the navigation moment, and we say if it's falling, then it can enter the transition, or it can enter this particular state like that. and we just hit compile and go back to locomotion, right? Okay, so we are done with the transition. We are done with the, the condition for the transition. Now we have to set up the state itself. When you go back here to the locomotion, when you double click on this jump start, it's going to be very similar to the it's going to be very similar to the movement state because they are all state. So now I want to have an animation being played here. So I'll go over to my asset browser and I'll look for my jump, and there are all these jump animations that are set up. So I'll drag and drop the jump forward, okay, and then just connect that with this, and then you also have, when I hit compile, you also get this little slider, okay, and this is just about the frame that you want to clip and whether you want to play the whole animation or not. But we're going to play the whole animation, so we won't be messing around with the slider here. That's okay. All right, so now with that setup, you can go back and set up the jump mid, okay, and we also set up the condition for the jump mid first. Okay, so for the transition, I'm going to double click on that again, and I'll be presented with this little graph with a lone node sitting there. So how do we do this is we have to figure out whether or not we are in jump mid. Okay, so for that I will right click and I'll just type in relev and relevant or relevant. So you have all of these things coming in. Now what this lets me do is, it first, if you look at the first one, it says get relevant animation length. The second one, it says get relevant animation time, then it says fraction, then it says fraction time remaining, then it says time remaining fraction. Okay, so now all of these quite useful functions when it comes to figure out whether the animation is still playing or whether it's done playing or how much of it is remaining, or yeah, and all of that fraction or exact time remaining. So you can select time remaining out here, and this says get relevant anim time remaining. So how much, like if the jump animation is about, let's say if I go back here, if I look in animations and if I look at jump forward, if I double click that, it's 6 frame and it's 0.167 seconds. Now I'll just look at it and I'll say, okay, let me try and see whether it's less than or equal to some value. Okay, I'm just going to say less than or equal to, okay, and I say less than or equal to 0.1. Okay, and if that's the case, then it can transition into the animation. Okay, with that, I'm just going to hit compile and I'm going to go back here and we're going to set up one by one by one. So first we set up the state. There is no transition here. It enters into the state and we set up the state like this. Okay, and then after that we set up the transition for the jump start with these lines of code with these nodes, and then we set up the animation itself, and then we just set up the transition for from jump start to jump mid, and now we're going to set up the animation for jump mid. Okay, now for the animation for jump mid, it's not going to be any jump animation, but this is going to be falling animation. So this, she says it's falling, player falling, so I'm just going to right click on that, and if I double click, and this is what it looks like. She just falls around like that. So that's perfect jump mid, and I connect that and compile. I don't need to save. Yeah, I need to because it's not really successful. And then I can go back here, and then there's this transition between jump mid and the landing. So for this transition, okay, so for this, it's rather simple. Go back to this transition out here. What we did from movement to jump start, the transition code is we look at the pawn owner, we get the component movement, we get whether it's falling or not, and then we set that inside the result as can enter transition, and that's it. So we're going to do something exactly similar, and we're going to go back here and we're going to say, we'll first say try get pawn owner, okay, and then we're going to get the movement component, and we again going to check whether it's falling. If it is, then we're going to toggle that value. We're going to negate that value by saying not boolean. Okay, we're going to say not, then we can enter the transition, right, and hit compile. So now get the owner, get the moment component, get if it's falling, and if it's not falling, then you enter that transition. Okay, and so if this is true, then she can obviously enter the transition of landing. Now of course for landing you have another animation that you have to set up. And for landing, we have land. And if I click that, and if I double click that, that's it. She lands. She lands. Her knees buckle a bit. They fold, they buckle, and then they land. Simple. And then I connect this, and that's it. So we have our jump set up. Okay, and it says a node result uses potentially thread unsafe calls, disable threaded update, or use a thread safe call. Function may need blueprint, but we're not going to enter that. That's okay. It's just landing to movement will never be taken because connect something to character transition. Got it? All right, fine. So going back here. So now the last piece of this whole cycle is this particular transition. So we have from movement to jump start, and from jump start to jump mid, and from jump mid to landing, and from land to movement is yet to be set up. So again, we click on this transition and we right click and we just say time remaining, and we just check how much the time remaining is. Now we're not going to be checking checking versus the time length, but we're just going to be looking for some arbitrary number. So we say 0 or less than equal to, again we're going to check for something like 0.1 because we know this animation is not greater than that. So if that's true, then we enter the transition and we can hit compile, and that's all okay. Let me go back here and save as well. So that's all it takes, not here. So that's all it takes to cycle between all of these states with the transitions and the animation setup. Okay, so now we can save this, and we can try and test this out, but we have to test it out inside character base or control base. So inside the controller base, what we are doing here, so you know what, we can actually get rid of this. We don't need that, or we can just get rid of this, and this need not fire at all. And if I just hit compile, and that's okay. So I'm going to create another custom event. I'm going to say custom event, and I'm going to say jump test. This is not going to be, this is just going to be for test, and jump test is going to do something very similar. I will select these guys and drag them down like that because we don't need her to wander right now. And this is going to do something very similar. We will first get control on, okay, and then again we check whether this is valid or not. So pull out a wire and we say is valid, and we get the question mark, which has it's not a pure function. Once that's done, if it is valid, then we're gonna say cast to character. Okay, once that's cast to character, and we're gonna say as character jump, okay, like that. And this can be connected. Let's say this can be set. We set a timer by event. Okay, and let's keep this at 7 seconds, and let her keep on jumping. Okay, so that way, let's see, compile. Okay, it says object is undefined, undetermined. Okay, and oh, like that. Compile, save, and then let's try and simulate this. Okay, and every 7 seconds she should jump. There you go, she jumps and she lands, and then 7 seconds later she should jump again. There you go. So she does a good job jumping. And except I'll go back to my controller base. All right, so now we know, the reason jump function wasn't available in direct pawn because pawn does not have a jump function, but a character has. That's why we had to cast it to a character, and then we could call the jump function that is built into the character. So if you go back to your character base and if you look at the character movement, and you can actually figure out how much the player jumps and all that, but we're not going to touch that. I'm just going to show it to you. You don't have, okay, if I just try and type in jump, I don't think you'll get anything. You do have the jump velocity, that's 420. Now you can say something like if the jump velocity is too high, let's say I'll change this to, I'll first copy this so that I don't lose it, and I'll double it up. I'll say 840. So let's see if she moves really quickly, and I'm just gonna hit go back here, and I'll simulate, and let's see how far she jumped. Does that even matter? There you go. So she's jumping quite high, and my Cortana opened up. So again, I'll try and make her jump again. There you go. So she jumped quite high. That's because of whatever you changed here. So I'm going back to my character movement, and I'll bring it down to 420. So that's good enough. So there you go. So now we have something which is about jump. We have set up the jump animations and everything is working. And in the next video, we're going to start applying inputs and start finding the different movements, like the movement and the jump with inputs. Okay, again, there is nothing called, if you go back to, the blueprint, we did not have to, set up a lot of event graphs here. We did, but it's just for a while. For the jump start, we had all of this jump. This is for the jump start state. I go back here, locomotion, and if I double click on that and event graph, so if I go back here, locomotion, if I click on this and I'm getting the pawn owner, I'm getting the moment, and I'm looking for whether it's falling or not. And if it is falling, then it enters the transition, and that's how she's able to get into the state, and that's how she's able to play this jump forward animation. Okay, as simple as that. And after that, I'm setting up the transition again, and in here I'm seeing whether the transition time or whether animation time remaining is less than 0.1. If it is, then she can enter the transition. Okay, and she can enter the transition and she can get into jump mid. So that's why she blends through the jump start, that little buckling of knees, and she's up there and she's kind of in the mid air. So if I click on this and if I double click on this, and so she does that pretty quickly because if I click on this, because this time frame is quite less. So, and she instantly enters a transition, so it's not very noticeable, but it's happening and it's very subtle. And then after that, she has to land, and then again when I click on this and it says what I'm doing in this state, from movement to jump start, I'm doing the exact opposite in this state. So I'm getting the exact same things and I'm negating that value of the boolean that's coming out from S falling, and then I'm setting that inside result, which is determining whether or not she should enter the transition of this particular landing from jump mid to landing. And inside jump mid, I've set up the play underscore land animation, and after that, and I just have to say whether I just have to check whether the time remaining for the player land animation is less than 0.1. If it is, then she can enter the transition and she can go back to her idle state again. So that's what is exactly happening here. So every 7 seconds, I am going to be watching her jump, and she's going to jump now, and then she does that. And in fact, you know what? I'm going to make that character movement, the jump. If I click here, jump factor, jump x, z velocity, I'm going to make that to 840 just for fun. And then I'm going to hit play, and then I'm going to hit simulate. I think the simulate is not going to work. I should come here and I should hit simulate here, and she should go really far, and now you can see most of the animation is being played, and there you go, and you can see that flapping of hands while she's in midair. So that's when she's playing that little, and there you go, and she buckles. When she falls, she buckles, and simple. Let's watch that again. There you go. Excellent. If you want to see that quite closely, then what we can do is, I think, go back to our character base, and let me just set up camera. This is purely experimental. Just want to see it if you want to see it. And camera, just drag that camera here and far away like that. And I'll just make a 180 degree. I hope it covers everything, the whole character. Okay, and then I'll just hit compile, and then I can say inside this, I'll just say, no, hang on, I'll just go over to my level blueprint, and inside begin play, okay, I will be clicking on this guy, and now I can see that she's fine, and I can see the entire animation in the whole, and I can go back to the main arena, and I can say right click and create a reference for character base, and then I can say, okay, so let's try set target view. I think just right click, target view, right click and get rid of the context sensitive target view with blend, set target view with blend. So, and then this can click here, or and then I can say the target is this, or this is the target, and let's see, and then I can say get layer controller. Let's see if this works, because that's the function that lets you switch cameras. So if I go over to my selected viewport, there I go, and now I'm actually looking at her from that camera, and now when she jumps, and I'm following her, and you can now follow her closely, and she jumps again, and you can see the flailing arms, and there she buckles the knees and drops there. So that's pretty useful, and I'll again go back to my simulate because I don't need to play that now. Of course, I can stop that, go back to my main arena, and get rid of this thing because I don't need it. Compile. I don't need my level blueprints. I did it in level blueprints because there was a rough thing. And again, character base. Click on the camera and just delete it. Hit compile, save, and then inside go back to night girl, not the night girl, character base or the controller base. Yeah, controller base, and let's get rid of this function right away because we don't need it. It's just a jump test, and if you want, we can. Actually, we don't, because this was again a wander function, which was again for test purposes only. And now when you hit simulate, she's not going to do anything. She's just going to be standing there, right? Okay, when I hit simulate, she's just going to be standing there because nothing is connected to her. So that's it. And now we have her jumping successfully and also landing perfectly well. And if I look at her closely, she's not entirely touching the ground. Yep. So if I can, I will just select her and move her up a bit, and then I hit end. And if I now go down and check where she is, I think she's now, yeah, she's now touching the ground. And again, if I, that's okay. I don't want to do that. So she's just looking kind of odd, but now she's looking fine. So that was about the jump animations in this video. In the next video, we're going to start setting up the input bindings and make her move based on the key presses and make her jump based on the key presses and all that. Okay, I'll see you in the next video. Welcome back. So now we have the basic workings of this character. However, she's not really moving based on our inputs, the player inputs. She's just moving around randomly and she's jumping around, and based on all of that, we have our animation setup, we have her material setup, and we have a little bit of the character setup. So going further down, we will be putting a sword in her hand so that she can wield and attack other people with that. And she also runs around, she jumps, and all of that good stuff. Now the next step is, of course, to make her move based on our input. So she needs to be under our control. She's not an AI character, she's a player character. So to create this player character, so we go to blueprints and we create a new controller. We already have an AI controller. We have this character base, which is also a blueprint. And now next up, we're going to be creating a player controller. Now a player controller is something that is actually the brain of the player. If an AI controller is the brain of the AI, then the player controller is going to be the brain of the player controller is going to be the brain of the player character. And this is where you write your input code normally, regardless of what engine you're using, whether you're using Unreal or Unity or something else. Normally people have their own player controller or player manager class where they have the input code inside, or they might also have a different input controller or an input manager class. But in this case, player controller is going to be it's going to suffice for us, because we will be writing our input code which will drive the player around in the level. Okay, so click on the player controller and name this player controller. Oh, player controller base, and double click on that and just work on this. Now for now, I'll just close animation blueprint and also close the AI controller base. I'll just keep the character base and the player controller base because that's what we might need, but player controller base is definitely what we're going to be working on now. Okay, so the viewport is going to have nothing. We're not going to fiddle around with the viewport at all. Instead, we jump straight into event graph and start coding right there. Okay, so the first thing before we add any input code is, if this game is going to be using a mouse, then we have to, you know, at all times check what's under the mouse. We want this to be controlled using the mouse. Like if I move my mouse like this, then I want my character to rotate. Okay, and depending on where my mouse is, I want the character to rotate. So that's more like a look at for the character, and the mouse being the input controller. Okay, so I'm going to create a new custom event. I'm going to say custom event, and I'm going to call this process mouse. Now this is going to be run every frame inside the event tick. uh, we might disconnect this, and if we are going to be using a controller in the future, then we do not need this, because the controller does not have a moving, a pointing device. So it already has those thumbsticks for giving the movement to the player or the character. So it does not need the process mouse when you're using a controller. But for now, since we're using a mouse, so we will be calling this guy every single frame. So process mouse. Okay, and for the first thing I'm going to do is I will be looking at what's under my mouse. So I'll right click and I'll say uh, get all. Okay, I'll just type mouse because that's a long one, and this is it's, let's say, get hit result. Yeah, so you have these four functions the moment you type get hit. So you have get hit result under cursor by channel, you have get hit result under cursor by for objects, so that will be scanning for specific objects. Then you'll say get hit result under finger by channel, this is for touch, and the second last one is also for touch. So these are the last two that's for touch, and the first two is for mouse. Okay, so I'll select the first one and get hit result under cursor by channel. So what this function does is it looks for something under your mouse. Okay, so if I have this mouse under, or actually, if under my cursor is this node, okay, so it's going to get this hit as a node is under your mouse. Okay, so if there is anything under my mouse, or just that I just want to check what's under my mouse, can I move there or something at all. So I just want to get what's there under my mouse, what am I pointing at. This is going to be something that will return whether it's true or not, whether there is something beneath the mouse or not. So we're gonna get a branch. We're gonna do a branch first. Okay, right, and then as I move my mouse around, I want to rotate my pawn. Okay, so the first thing is I'm going to get control pawn. I want to control the rotation of my pawn wherever my mouse is pointing. So I'm going to get the control pawn, and I will be, let's say, setting the actor's rotation. So I'll just pull out a Y from here and I'll say set actor rotation, like that. And of course, if that is true, so let's connect the true with this and move this far ahead because we need some room. Okay, so before we process any of this, we first have to check whether there is even a control pawn. So I'm gonna move this back a little bit, and I will say get control pawn, get control pawn. Okay, and we just want to check if it's even valid, and for that we say is valid. Okay, for some reason if it's not valid, then it might not end well, so we just want to check this before we proceed. If only if it's valid, we want to go ahead and process this. Okay, like that. Okay, now now we have to set our actor's rotation. So how do we do that? So the first thing is I'm going to move this guy here, a little bit here. Okay, so what I'm going to do is I'm going to bring this hit result and I'm going to break it. Okay, you can, there it says break hit result, so I'm going to click on that, and that will expose all the variables that is inside the hit result. So one look at all of these variables. You have blocking hit, initial overlap, time, location, impact point, normal, impact normal, physics material, hit actor, hit component, hit bone name, hit item, face index, trace start, and trace end. Now the only relevant one that it appears apparently that we want to be using in for our situation is the location. So what we're gonna do is from the location we're gonna get the direction. This is the location of where it's looking. Okay, I mean where the mouse is, or where the mouse or which object, about which object the mouse cursor. So that is the location. So from there I'm gonna get the unit direction vector that gives me the direction from my character to where this object is. So what this does is it gets the direction from this to this. Okay, now we don't want to get the direction from where this location is to our character. Instead we want to get the direction from our character to this particular location. So even though this is attached to from, I'm going to move this down to 2, and this is going to be our location. Okay, so again I'm going to move this guy a little bit to the right. Okay, and move this guy and bring him here like that. Move this guy further away to the right. Okay, and this is going to be get actor location. This is going to be our location, right? And so now it actually forms the logic as from our location to the location that the mouse cursor found